Welcome to Siram Tripoli YouTube channel. Let us discuss single line to ground faults on the unloaded generator. So just to consider synchronous generator. So terminal condition will get VA is equal to 0 because this one is a unloaded generator. There is no voltage development. I mean, like open in the sense, definitely you will get 0 output, and then IB is equal to 0, IC is equal to 0, right? So this is a basic common sense. If suppose unloaded generator open will be there, so one touches one wire touches to ground or line to ground, so what happens? 0 potential will get it. Okay. And next we have one diagram here. See, there is a single line to ground fault. See, single line and then grounded over here, so IA will be there, IB is equal to 0, IC is equal to 0. Already we have taken equations. So Zn is a impedance, neutral impedance, so it is star connected load, right? Star connected. So EA, EB, EB, AC are the generating voltages in the generator, right? So symmetrical components relation, since two conditions are available regarding the line current, so it is convenient to transform the term them into conditions in terms of symmetrical components. So already we know, right? IA naught is equal to 1 by 3 IA plus IB plus IC. So if it is LG fault, will get 0 0 in the IBAC, so definitely will get 1 by 3 IA, right? And so in this IA1 positive sequence component, so 1 by 3 IA, A plus A into IB, A square AC, just to substitute over here, you will get 1 by 3 IA. And here also same IA2 negative sequence component, so same thing will get 1 by 3 IA. So finally IA1 is equal to IA2 is equal to IA0 is equal to 1 by 3 IA. So the term conditions of VA is equal to 0 gives VA naught VA1 plus VA2 is equal to 0. So just to take one equation here, and interconnection sequence network is like this. Okay, so EA Z1 Z2 Z0. So positive sequence, this one is negative sequence, and then this one is zero sequence component, right? So likewise you have to draw the circuit diagram for calculation purpose, but first you draw the reactance diagram. After that you this one positive sequence voltage must be there, and negative sequence only reactance, zero sequence you have to not ZG naught, right? So since equation quantities like the following relation can be directly obtained, IA1 IA2 IA0 is equal to E0 plus Z1 Z2 Z0, just to apply KVL. Okay, so what you will get it here, back you go back and see here, this one is a loop. Okay, see this one is a, complete loop, right? So just to apply you will get E A divided by Z1 plus Z2 plus Z3. These are series. Okay, series. And that's why we got here the equation is this one, EA by according to Ohm's law, I is equal to V by Z, that's all. And V1 is equal to EA1 into minus IA1 Z1. So finally you will get this equation, and EA into Z2 into Z0 divided by Z2 plus Z0 divided by Z1 plus Z2 plus Z0. So VA2 is equal to what? Minus IA2 Z2, right? The equation already we got from the derivation, a loaded generator, and VA Z2. Just to substitute the values, so what is IA2 and then what is IA0, okay? And you'll get the equation like this. So fault current, if you want to calculate fault current, the fault current IF in this case equal to current phase A given as IF is equal to IA is equal to 3 IA0. So sorry for the inconvenience. The fault current, if you want to calculate, IF in this case is equal to the current in phase A. Current is given as 3 INR, 3 times of zero sequence current. So 3 EA divided by Z1 Z2 plus Z0. So INR is equal to what? EA by Z1 plus Z2 plus Z0. EA by A, that's series circuit, right? And in the case of neutral of the generator is not grounded, then Z0 is equal to Zg0 plus 3Zn. So if it is not grounded, okay, so Zg0 plus infinity is equal to infinity. Therefore, the fault current is If is equal to 3 into Ea by Z1 plus Z2 plus infinity. So because if it is neutral, in the case of neutral of the generator is not grounded, so what is the this one? I mean, like fault impedance or zero sequence impedance. So we'll get infinity, right? So that's a concept, fault current in the single end to ground faults. Here, practically we can expect this type of fault in the transmission lines. If suppose one line will be there, that line power supply is coming and then from the transmission from the power plant, and if suppose that wire falling down into the earth, I mean ground level, what happens that touches the ground, so whatever the power directly goes to the, I mean like electrons will move that infinite resistance of the ground, like earthing, okay, just to remember like a earthing. So why do we do like earthing? So because of for safety purpose, right? If suppose if you touch the body of the equipment, you will not get shock, in the sense that's a safety, equipment safety. So what happens, the power single phasing occurs sometimes. If suppose three lines we are using, so if the another one wire touches the ground, what happens, single phasing will occurs, and then will not get proper voltage or proper current to the appliances or equipment. So that's why it's called as a fault current. Even the fault current I mean like particularly we are using current, not voltage, because voltage is constant. So current reaches the limit, current reaches beyond the limit, what happens, automatically some abnormal condition occurs, automatically that MC will get trip off in the main station, right?